Hi everyone, Caleb Dennis here from Team 1069E here. Today I have a 4-minute tutorial for you on multi-threading. Now what is multi-threading, you may ask? Well, here's a quick analogy for you that'll help you better understand how exactly this can benefit you. A simple analogy you can use to help remember multi-threading is to think of a man faced with reading a very long book, possibly even 600 pages in length. This would take any normal person a considerable amount of time to read. This is your robot reading instructions step by step without multi-threading. This man can read the book completely by himself without help, or he could have a series of well-trained clones read chunks of the book at the same time. This will cut the overall read time in half for him. The same principle can be applied to robotics, and it is known as multi-threading, as explained before. This entire process will be explained in the next few minutes. Now that you have a basic understanding of how multi-threading works, we can explain how you would apply it in your robot. Say for example, you wanted your robot to back up while the arm was raising. Now you couldn't normally do this without multi-threading. So what you would do is define a procedure that raises the arm. Rather than using void, you would use task. This is so that the function start task can reference it later. In the task, you define the motors and the speed you want to set them to. Of course, this is sample code. You can replace the code with whatever you'd like. This is just the groundwork for future programs. After you've defined the task, you can call it in the main level using the function startTask. In the place of the brackets, you import the name of the task you just defined. Now, when that main program is run, that start task will be detected and that task will be executed on top of the main program. This is how multi-threading gets started in your Cortex. Keep in mind though that the Cortex only supports up to 16 channels of threading on the system. This can cause problems for extremely advanced automations, however it's highly doubtful that anyone would need more than 16. Congratulations, you've reached the end of this wonderful little video. Here are some little pointers that can help you out. Pointer number 1, don't overcomplicate things. As much as you love to make your code look fantastic, you don't want it to look like spaghetti. Make sure everything is nice and neat, otherwise debugging down the road will be much more difficult. Tip number 2, never ever use more than 16 tasks, as it's frowned upon and physically impossible. Using multiple tasks, such as more than 5, may cause the Cortex slight stress depending on how much you need to calculate or the certain actions going on. Number 3, don't ever put start task inside a while loop. This will essentially keep creating tasks infinitely until the 16 port slot is filled up. This will cause the processor to crash, and that's even worse if it happens during competition. Unfortunately, the compiler won't warn you about this, so don't ever do that. Thank you for watching our video. I hope you found it slightly informative, especially the new programmers. This must be helpful in some way. Our website is posted in either description. If this is on YouTube, then it will be below. If this is on the competition, it will also be below. I hope you got a kick out of this video. I got a slight kick out of making it myself. Donations are accepted on our website. More details posted below. Thank you. Bye.